Determine whether each statement is true or false. 8, this is how we read example A. 8 is an element of 1, 2, 3, and we have 3 dots, and then we have 10. The 3 dots represent the digits between 3 and 10. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is 8 an element of this set that we have that's shown? Yes, so we would say true. Letter B, lowercase r is not an element of A, B, C, and Z. That is true because r is not in that set. Letter C, Monday is an element of, we have for all x's such that X is a day of the week. Now, because Monday is placed in braces, what this means is Monday is the only day of the week, and this is not true. Monday is not the only day of the week. Okay? We have more days of the week, Monday through Sunday, so we would say false. Example 6. Express each of the following sets using the roster method. Set A is the set of natural numbers less than or equal to 3. So let's talk about natural numbers. Natural numbers they're also known as our counting numbers. So when you were taught how to count, we began with 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We never started off with 0. So also known as our counting numbers. Natural numbers are positive numbers only. Beginning with the number 1. Natural numbers are you don't have any fractions, you don't have any decimals, but positive numbers only, beginning with 1. So here I have the set of natural numbers. You start with 1, all positive, and we go to infinity. So back to 6A. Set A is the set of natural numbers less than or equal to 3. We want to represent those numbers. So set A is equal to, and the braces, what will we have here? 1, 2, 3. And that is it, because we're saying all numbers that are less than or equal to 3. So 3 would be included in that set. Letter B. Set B is a set of natural numbers greater than 14. So my question to you is, will 14 be part of this set? Will be the elements in the parentheses? No, but we're looking for all numbers that are greater than 14. 15, 16, 17, 18. We can keep going. We write 3 dots, which means it's continuous. Letter C. We have here set O is equal to. This is for all x's such that x is an element of. The symbol that should be written here is N. And let me go back to the natural numbers. The symbol that's used for natural numbers, so follow me and watch how I write this out. We have here 2 lines kind of close together. Make that first line kind of thick there. when you're writing the letter N, but this is what the notation we would use for natural numbers. It says, for all x's such that x is an element of natural numbers and x is odd. Okay, so our set O, think about natural numbers. It begins with 1, and our x's are going to be odd. 1, 3, 5, here are the following elements, 7, and we can keep going. Letter D. Says we're going to express each of the following using the roster method. So we're going to give this example a set name. So we have here for all x's such that x is an element of natural numbers and x is less than 200. So we're looking at all numbers that are less than 200, but they're natural numbers. So we can call this set T equals to 1, 2, 3, 4. It didn't say that x was odd. It didn't say x was even. It just said that x was less than 200, and they were natural numbers. We can keep going up to 99. All numbers that are less than 200. 200 cannot be included in that set. Letter E. For all x's such that x is an element of natural numbers again. And 50 less than x less than or equal to 200. So our roster method set I. And we're looking at what this is saying. All natural numbers that are between 50 and 200. Not including 50, but including 200, because you have the equal to, less than or equal to, between the x and the 200. So we have here 51, 52, 53, 54, keep going all the way to 200. We can just write the 3 dots. We don't want to write 51 to 200. That would just take up too much space. Last concept for this section here. The cardinal number of a set A is represented with N, the variable N, and in parentheses the set, the name of that set, is the number of distinct elements in set A. Repeating elements in a set neither adds new elements to the set nor changes its cardinality. Example 7. Find the cardinal number of each of the following sets. So a cardinal number is the number of distinct elements. Distinct meaning recognizable elements, specific elements, clear-cut elements, explicit elements. That's what distinct means. So as we look at letter A, our roster method here, A is equal to, we have 6, or set A is equal to 6, 10, 14, 15, and 16. How many distinct elements do we have in this set here, between the braces? So we will write it out as our set here, N. Our set, we call it A, equals to. What do we have? We have 1, 2, 3, 4, 5. We have 5 distinct elements in set A. Example B. Set B is equal to 872. How many distinct elements do we have here? We just have one number, which is 872. Here we go. N and describe our set. B. The cardinal number for set B, or of set B, is 1. Let's do D, and we're going to come back to letter C. Letter D. Set D is equal to, we have an empty set. What will be the cardinal number of set D? The cardinal number of set D is 0, because this empty set contains no elements. Letter C. We have set C. Set C is equal to 9, 10, 11. We have 3 dots, and then 15, 16. Now, how could we find the number of distinct elements in set C? Well, what we're going to have to do, it says we want to find the difference between each element of the set. Okay? And what we're going to do is we're going to take the higher number, 16, okay, and subtract it to the lower number, which is 9. So we're going to find it. Now, this one is easy enough for us. We can count it out. But what if we had 3-digit numbers? What if this was 9, the lower number was 9, the higher number was 246? Then there is no way other than writing this out to find the number of distinct elements, but we have a formula that we can use. So subtract the lower number from the higher number. So we have 16 minus 9, which gives us 7. Then we're going to look at the pattern of this set. So I want you to look at it. To get from 9 to 10, 10 to 11, 11 to 12, 12 to 13, what are we doing each time? We're adding 1, okay? So I want you to look at the pattern. So from that pattern, what we're going to do is take the 7, since we're increasing by 1 each time, you're going to divide by 1, which is 7, and then take the 7 and add 1 to that, and we have 8. So the number of distinct elements we have, for example, C, is 8. So the cardinal number of set C equals 8.